All right, let's compare some functions here and the values of the different functions as they change and see how it changes the graph. This is Desmos. It's a pretty useful tool to see how functions are. So here is our exponential function. All right, I called it L sub x. L sub x equals a times b raised to the x, right? Where a is the magnitude at which it grows, and b is the starting point. You guys remember, and x is the x value along the x-axis, right? You should recognize that these two are similar. I don't know if you can see my. What does it look like? These two are similar. Um, this one and this one are similar in that it's a times parentheses or absolute value of x minus h and then plus k. The only difference is the squared here and the absolute value bars. This is an absolute value bar function, and a is the scale at which it grows or how fast it grows, and h is the um, x value of the vertex. Remember, it's negative, so it's the opposite value of the vertex, and k is the y value of the vertex. And then this g sub x is just this is in vertex form. F sub x is in vertex form, and g sub x is in standard form. All right, so they're effectively the same equations, just in different forms. Okay, so let's look at these ones with the h's in it, right? And first, let's change a. Right, so right now I have a is 0, so it makes everything attached to a equals 0, so everything is 0 on the line. But let's say I just make a up to 1, and now you can better see that I have f sub x and g sub x is the red right here. It's the same thing, and then I have the absolute value right there at the vertex of h is 0 and k is 0. Right, and the green one, you really can't see nothing yet because I have b as 0, so it's b raised into the 0th, so this is just 0. Right, so but if I raise b up a little bit, you'll start seeing an exponential. Where's b in this one? So b is changing in this one over here, and it's changing in a times b to the x. Right, so if, as you see, as I shift b around, right, and I make it positive, you see the green function here comes into play. I'll just set b to 2. I don't think 1 will work. We'll do 2. Right, and then notice the green function, that's L sub x. Right, it has a starting point at 2, and then at 1 it's 4, and at 2, sorry, at 1 it's 2, at 2 it's 4, at 4 or at 3 it is 8, and then at 4 it's all the way up here at 16. Right, so you can see that those are a little different, are as expected, but the g sub x changes as b changes pretty interestingly. Right, you can see how it shifts to -2 and -2 when b equals 2. If I go to -3 and -3, it's a little bit off. It's even weirder, right? So the b term in g sub x is kind of not as intuitive as the rest of the ones. So I'm not going to talk too much about shifting the b term in a quadratic equation, these parabolas right here, right? So I'm going to go ahead and bring, I'll keep that there at 2. We'll keep it at 2. Okay, so up here, my thing in my parabola in vertex form hasn't been changed because I haven't changed the vertex values. If I wanted this to be the same, right, this would have to be, k would have to become positive, negative, because it'll make it go down, right? And remember, h has to, if you want to make it, because of that negative sign in front of it, if I want to make it shift over, I have to do the opposite way I want to go. So I have to move that over like that. And now you can see that I have h at 2 and k, h at k at -1 and h at -1, right? And that kind of lines up and makes the same function as of that. And notice when I changed h and k, it changed the vertex x value for both. This is changing h, so it changes the vertex value of both the parabola and the absolute value function. Okay, if I want to shift it upwards, I change the k value. That's going to change where my vertex is. Okay, and then remember that b is the y-intercept, right? Except for when it's in this form. C is the y-intercept. If I want to shift this up, C then becomes the y-intercept. So that's how it's a little different in standard form. So let's get rid of standard form here, just to make it a little bit more intuitive here. All right, so now let's shift this back to 0 and this back to 0. And we're back on the origin as the vertex. Now, if I want to make these like wider or narrower parabolas or absolute values, or if I want to bring the two v's together, or if I want to bring the legs of the parabola closer together, I need to change or spread them further apart. I need to change the a value, right? That's going to change the rate at which the change in x affects the change in y. Okay, so here is a visual representation of that, right? So if I bring this thing up, y is going to change faster than x, so it's going to be skinnier. Everything's going to get skinnier, right? And the exponential function gets bigger faster when a gets bigger or more than 1, right? Everything gets skinnier closer together because for every change in x, there's a bigger change in y, right? Right here, it's a 1-to-1 ratio. Right here, it's a 2-to-1 ratio. Right here, it's a 3-to-1 ratio. Right? So it's going to get, as you make this a value bigger, it brings everything together. And if I make it smaller than 0 but greater than 1, it's still all going to be positive, right? But it gets wider and wider and wider and wider until it becomes negative. And then it just is a mirror almost of, it is a mirror of what is going on up top with the same stuff. So when it turns negative, you see A is going to negative. It just flips everything into the negative quadrant. Everything just gets flipped into the negative y quadrants, 3 and 4. Okay, so that's how you make mirror images or reflections of something. Is you just kind of shift them back and forth, right? So to make everything shrink horizontally, right? You increase A to be greater than 1. To make them spread out, you increase A all the way up to, or you decrease A as closer to 0 it gets, the more widespread it gets, because for this instance, when it's 0.1, that means for every it takes 10 changes in x for y to go up just 1, or 1 change in y is x of x is 0.1 changes in y. All right, so hopefully you guys can go to Desmos and type this stuff in and play with things like that, and ask for the slider in there, and you can add the sliders, and it's pretty helpful tool to kind of see what happens when I change the different values in these standard equations. Okay, hopefully that makes some sense, and we'll get on to some examples.